Okay, good morning, everyone. Can you hear me?
Yes, sir.
Okay, thank you. Um, let's start another section where this is a bit off from the syllabus, but I thought this will be very helpful looking at the current infrastructures that are available for databases as well as machine learning. So the course is specifically talk about the advanced databases, which means we have to talk about databases and also learning from the data, which is machine learning. So now the data becomes huge, which means we have to talk about the big data analytics. So this is a new addition to the syllabus. So having said that, in this session, we are going to talk about brief on what big data analytics means, what particularly for our module, the interest is what big data is, and what are the possible, our technologies available for handling big data, with a very brief introduction to the topic. So what I'm planning to discuss in today's session, we'll talk about what big data is, giving you some examples, some characteristics, challenges, and also the deployment consideration, focusing on Apache Hadoop. So that's the plan. Having said that, let's start looking at what big data is. So looking at the big data, if you look at what we have, simply it refers large data sets. And again, why we have to use large data sets? So with the background of machine learning and also artificial intelligence, boom, you know that you have more the data, you have better the predictions, which means we tend to work with very large data set nowadays. And also, if you look at the applications, especially in social media, you will notice that there are a lot of data generated, which is very interesting. We look for some interesting pattern and trends. So if you look at the definition from big data, so if I'm taking the definition from the textbooks that we have recommended, Elmastry and Nawat, they said the big data refers to the data set whose size is beyond the ability of typical database software management tools uh, to capture, storage, manage, and analyze. So the right now we discuss about MySQL or MariaDB. And then in coming session, we can talk about the other relational database. For example, if you're interested in Oracle, for example, and another one we are going to look at is like MongoDB. But typical ones like the relational database that you discuss may not be able to handle very large data. So that is where we defined what big data is. If you look at another definition from Ed Dumble, is that it sees the processing capacity of the conventional database system, which is very similar to the Elmastry's definition. So the data is too big or it's moved too fast, which means the frequent changes or adding more data. So it will not fit the structures that we discuss in your database architecture. So the traditional architectures, if your traditional, or for example, what we have discussed so far is a relational database architectures where we have related tables, where we have a fixed set of columns and all. So if your traditional databases couldn't handle what the requirements for the new data, then we can call it a big data. Right now, if you look at like the resources what we have, there are two main giants of handling this. So you can see the Amazon and the Google, they have their own way of handling the high demand of handling this. Okay, Now let's briefly talk about the examples. Clickstream data, which means like, for example, people used to visit the websites. For example, as an organization, we might interest in what customers are looking at. So you can record all customer interactions, which we call the clickstream data. So if you assuming that there are millions of users are interacting with your organization website, then it will be huge, right? But this is very interesting to see like what exact, if you want to determine what exactly your customer requirements are. Similar to that, social networks, of course, everybody is using this, which generates huge amount of data and very interesting in case if you want to know more about the data generated in these places. Then we have smartphone location-based services. Everybody uses smartphone nowadays, which generates again a huge amount of data, which is very interesting and with a huge commercial potential. Then those who are interested in networking or the servers, that server blogs is another interesting place. Even for myself, actually, I have worked with my students on, analyzing how students were using in the internet, for example, in the university environment in previously, or else like if you want to determine what kind of a threats that you might get from the outside. So those kind of analysis could be done using web server logs. Then data streams from the instruments, especially in IoT related. I know some of you are working in IoT related projects. That data comes in various sources. For example, in agriculture, for example, you can think about greenhouses where you can make measurements using various sensors and then make predictions. But then again, the data, if you look at the aspects of data, then it will be huge again. Then real-time trading data, the financial domain is very interesting. For example, if you look at like what is happening in the Bitcoin, for example, if you look at what has happened last few weeks, it recorded the highest value. If you have invested, 2-3 years back, you will get the return of, I think, multiple times. And people are interesting and people are working on it. The predictions that automated is very important. Again, that you have to record this, which we can consider as big data. Then again, the blocks people use to express themselves in various blocks. For example, in IT domain, maybe we will also read a lot of books related to IT domain, especially nowadays AI. Again, very interesting area of domain that we can actually collect the data. Then social media, Twitter, Facebook, and also Instagram, for example. These are like some of the examples of places where you can think applications or example for big data sources. And apart from this, there are many other places which we didn't discuss. For example, even the government produce a lot of documentation. Maybe most of the time they are in manually, but then again, nowadays, even in our country, now they are becoming digital, like in PDF. I think if you look at even in the university settings, now we generate a lot of even our, handouts, the exercises, the assignments, everything will be digital, which means again a good source where if you are interested in looking for a pattern. Right, so those are the examples. Now let's switch to discuss the characteristics. Now, how do you define the data is big? That is where we are going to discuss. So that means different aspects of big data, where they are used, and how do you understand the nature of this data. The first one is, I think everybody agrees, the size of the data. So the volume, more data, right? Is better than, having better models. So that's why people are used to collect more and more and more and data. So if you look at like sensor data, genome sequencing, remote sensing, environment monitoring, traffic monitoring, remote monitoring of patients, and inventory control is radio frequency devices. These are like some of the examples where we can think of the size of the data. So of course, one characteristic that we can look for is the volume. If that means the size of the data. So these are called like multiple V's. You can see that all these characteristics. So most common one, 3 V's, but in my case, I'm actually talking about 4 V's, but there are many V's. You can read about, if you're interested. The second one is the velocity, which means the speed of the data is created. If you look at like what is happening, like, for example, places like YouTube, Facebook, the Instagram and Twitter X generate a huge amount of data. The speed we couldn't control and we couldn't store ourselves, like in person, for example. It's impossible to manage. So the speed at which the data is created, accumulated, and ingested, and process which comes under the velocity, right? So for example, if you are interested in the financial domain, the data generated in the stock exchanges, it's huge. Right, next we, the type of sources. So you see that the data, okay, maybe you are focusing on one application, but there will be multiple sources of multiple varieties as well, right? So sometimes in machine learning, we talk about multimodal data. We talk about learning from multimodal data sets, which means, for example, patient records. If let's say we are going to predict a patient's disease. So it's not just sometimes the text data. You can use text data, which is collected as, let's say, as a kind of a spreadsheet, maybe. Then maybe there could be X-rays and other types of images, maybe videos, maybe voices. You can combine everything to make some predictions, for example, which means that there are different types or different types of sources are available. For example, you can talk about the click stream, which means how people are interacting with your application, social media, or research data. You can have surveys, or you can look for reports, the location details, images in various different modes, emails, supply chain data, especially in the marketing, or especially business domain, signal data, and even the videos. The other one is like these are in different forms. In relational databases, we talk about the structured data, like you have set of columns and then the rows. But then again, if you look at things like HTML, we can say, okay, they are semi-structured. And then if you just look at places like a blog post or the Facebook post, then it will be unstructured. So that means you have a variety of sources, variety of formats. Okay, the last one is again very important, which we call the veracity, which means the credibility of this source or suitability of the data. Like, although there are a lot of data is available, this all data will not be relevant for your analysis. So some are not uncertain, they might not complete, we call incomplete, or they may not accurate, inaccurate. So you need the quality testing before you are going to make the analysis from the data. So that is what we talk about under veracity. So I think now you are comfortable with the 4 characteristics that talk about the big data. But remember, there are many V's you can focus on. If you look at the research papers, people are still working on different types of characteristics. Things have changed over the time, but mainly people talk about like 3 V's, but here we talk about the 4 main V's. Since we talk about the structured and semi-structured and structured data, just give me a slide on this. So here is an example, kind of a same data, similar data, but in different forms, same information in different forms. This slide I have taken from the internet. So which talks about how the free text data, or we can say unstructured data. So it's free text. And then if you put into a format like XML, which we will discuss in coming sessions, which we call semi-structured, which you have some kind of a structure we define. But then the last one, you will see very structured, like what we discuss in the related relational databases, relational database tables. So what you notice is in unstructured data, it's not organized. So there's no predefined manner or how particular model as such. So the data, it might be coming from words, PDF, even the text, or even in the logs. Usually you will get the data in this unstructured data form. Then semi-structured data, it's not relational, but you have some organization. So XML, I already told you about this. But the final one is well-structured one, which we use normally to SQL to extract. Right, now that we talk about the different structures, let's move on to the challenges. Challenges in big data. Okay, so you can have, there are many challenges, and you can see most of the time the problem, according to this figure, again, I have taken this from the textbook. And according to this, you can see the more problems or the more challenging part would be the data growth, right? Then you will see data infrastructure, governance, integration, velocity, variety, and then also compliance, visualization. So these are the challenges that you need to face when you're handling big data. Right. Okay, this slide just simply just to say that this is bit all, but I think that you can take the point out of this, which is to show the rapid growth of unstructured data. Although so far we talk about the structured data in our database course and also the advanced database course, the future mostly depend on unstructured data, which we need, which is very interesting, which is very useful for our predictions. Right. Having said that, just I'm going to take one or two, like Facebook. The statistics might not accurate. The last time when I presented, this is like 2 years back, I prepared, so you can look for the recent statistics. So by that time, it was about like 300 petabytes. Process per day about like 600 terabytes. Number of users at that time 1 billion, likes 2.7 billion. The photos uploaded per day about like 300 million. So you can see the amount of data is collected in one single source. Similar to that, if you look at the Google, again 15 exabytes, 1000 petabytes processed per day, and number of pages indexed around like 60 trillion. Unique search users per month more than 1 billion, and searches per second is 2.3 million. So you can see it's huge, and it will show you like the intents of the data that we need to handle. Okay, so usually traditional way will not work. So therefore, we need to work with distributed architectures. Now, usually, so far, or maybe traditionally, what we used to have, everything will be in a single place, and you are going to handle everything in a single point of time. So in a single machine, which we call monolithic system. Whereas nowadays, with this extension, so you can see it's distributed everywhere. So you will have multiple machines, multiple processes, especially with the cloud environment. And if you look at like Google, for example, we talk about the search, and Google infrastructure located is in multiple geographical locations. And when you perform a search, it will come from multiple sources, right? So we will have distributed system. I think we discussed the basics last session. So you can read more on how people handle, multiple different nodes when you have. For example, the last session, one of the interesting is how you perform a SQL statement, how the query is handled. One idea we discussed now, for example, when we write SQL statement in our own machine, everything is available there. But when you have multiple nodes, some part of the data in some other place, and which you need to transfer data from one place to another place, which again, we did some calculations, which is very interesting to see like how you may perform, and optimizing the core execution will be a bit complex when you compare to monolithic architecture. Okay, so with that said, we will come to discuss what Apache Hadoop is. Right. So having said that, let's start looking at what Apache Hadoop is. So now we were discussing about the technologies available. And in this particular case, it's interesting to know how you might handle the large databases. So there are many frameworks are available, but in my case, I'm focusing on Apache Hadoop. Right. So if you look at Apache, Hadoop, in this one is a software platform that we are going to talk about, which we will have possible to manage huge amount of data. And also we can handle various type of, data as well. We talk about that nowadays we have requirements of handling structured, semi-structured, as well as unstructured data, right? So that's what we have discussed. Again, this software platform also supports of what we call the predictive, analysis or data mining, machine learning stuff, which again, we can talk about the details. I'm going to briefly look at what is available, right? And then, and also these system also talk about how to store them, and how to allocate system resources, because it'll be huge, and how do you handle them? And also these systems handle how to process when you have multiple tasks, right? And usually we talk about it's an ecosystem where you have multiple different services we put into one single place. But then if you look at the others, there are many other similar systems are available. Apache Spark, Apache Flink, Apache Kafka, and Apache Storm, Apache Samsa, and Google BigQuery is what is like under the Google's one. And if you look at compare with the revival with the Google is we call Amazon Redshift. So these are like some of them. In Microsoft domain, we have Microsoft Azure HD Insight could be another example. So these are like some of the things you can actually search more on this. But let's look at one of these, which is came in the very beginning with big data. So if you first compare what is the difference from previous, previously we talk about what we call the data warehouses, especially data, we have databases, and we talk about one single platform to manage everything, which we call the data warehouses. So then the problem with that is when you have various different types formats, especially we talk about the structured, unstructured, semi-structured, right? So the problem with the data warehouses, as you cannot manage the huge amount of data. So we can talk about Hadoop. In Hadoop, what we call, as I told you earlier, we call it's a ecosystem. By saying it's an ecosystem, you have various different services to handle different things that you need to handle in big data. So let's start each and every layer or modules, and let's try to understand what is happening each and every place, right? So the core component that we want to discuss is two places we want to discuss. I will talk about this in the next slide. One is MapReduce, which means we talk about splitting jobs into what we call the multiple tasks. And then what happens in the MapReduce in simply when you get a query, it will divide and run over multiple places. I told you, like in Google, for example, the data will be in multiple different geographical locations. So the distribution, this computation will handle the problem handling in a very large data is a one single place, right? Okay, so Hadoop, the term actually is the what we call the MapReduce implementation, which I have described early, where you get the query and divide into multiple run in multiple different nodes. So Hadoop is to represent the entire the ecosystem. Right. Let's look at the lower level of this. What happens in this one? In MapReduce, I told you, like, you distribute the computation on multiple places. So each server have to access to the data, and that is the role of what we call the Hadoop distributed file system, which in short we say HDFS. Right. And then when you take all the nodes together, we can talk about the Hadoop cluster. So the servers in the cluster can fail, but you are not going, that failure will not affects the whole computation process. So what happens with this file distributed file system is you make sure that there's a replication and also redundancy. I think we discussed these ideas earlier as well, which means that is how you handle. So the data is replicated so that the failure of one node will not affect the other nodes. At the same time, it will allow to store various different types of data, including structured, semi-structured, and unstructured, right? So those are the contributions or the support that we will get from Hadoop distributed file system, right? Okay, I think those are the things that I want to highlight on this, just to give you like how you may actually handle the MapReduce. Okay, so this actually I have taken from Edureka, one of the courses. So you can see various different processes within this MapReduce. So the problem here is counting number of words. So the input, you can see you have 3 documents. Let's say these are 3 documents. And then you can put them into three different documents. That means the data, assuming that it's huge, you are going to split into 3 pieces. And then you performs the operation, which means we want to count the number of words. So that's what we do in the mapping. And then you performs the shuffling, which means now since the word counts are taken in the different nodes, then you have to actually put them together. You have to merge, for example, the term bear appears in multiple places. So you put them together so that you get counts separately. Now then you can actually merge the results that we call reduce, which means the multiple values that you have get from multiple nodes put into one single place, and then you combine the final result. So this is like simple representation of how we can use MapReduce. Right, I hope now you got a basic idea how a query might, perform in multiple different nodes. Okay. So having said that, let's look at the points in here. There's a question on, although they run in distributor final, do they have to come to a single server and find? Okay, in the sense that when you talk about this, it will be transparent. Now, for example, it might be this question, Rithma asked the question. Rithma, it's like, as a user, you don't see this coming from multiple different places. It's like you perform Google query. Do you feel that the data coming from multiple places? No, right? So as a user, you don't see that, right? It doesn't necessarily come to a one single place. It will directly come to a user interface. In our case, when you perform the Google query, right, and the MapReduce will produce break into multiple different places, combine it in produce. So that's exactly what is happening. So there will be a one place, as you said, where it will distribute the query, and that place will combine and send it to you. But as a user, you will not feel that the data will come from multiple different sources. Okay, right. Having said that, let's look at the parts. The other one, the one we can talk about is called yarn. We call yet another resource negotiator. So this component is there for managing resources. So it will manage and schedule the resources for the running applications. So you can think of it as an operating system for Hadoop, right? So basically, it will manage and monitor the workloads. So this will allow multiple data processing engines to handle the data in HDFS. And then it can perform things like real-time streaming, batch processing, right? To handle data stored on a single platform. Right, then we have other tools, depend on your requirements. Two common ones we are going to talk about are called Pig and Hive. So Pig usually used for simplifying the common task. So things like loading data, transformations, and also storing final results. So those are the things that you use for Pig. The learning, for example, from semi-structured data. So for that, we can use Pig. So the Pig scripting we normally use for that. It's a scripting language. So this can be used to develop what we call the MapReduce applications. Then we have Hive. Hive is like data warehousing and SQL-like query language interface for the Hadoop. So you can perform the SQL-like syntax you can use for based on the data stored in HDFS. Then uh, um, uh, if you compare the Pig and Hive, usually we can consider them as a higher level of interface. And as I told you earlier, Hive is more on data warehousing task. Like I told you, like in data warehousing means like when you have multiple sources, we are putting into a single platform and you can perform the query on this. And Pig is to explore the large data sets, right? So those are the some examples. Right. If you compare the Pig, Apache Pig and MapReduce, again, if you look at the Pig, it is usually used for high-level data flow tool, especially Hadoop MapReduce usually used for the low-level data. And you don't need to write complex programs, but usually in Hadoop, you have to write, programs. You can use either Java or Python. Then third one is it supports joins, filters, ordering, and sorting. But then again, Hadoop usually is the data operations in here, the MapReduce. And then also it support nested data types. In those data types not available in MapReduce, just to compare the two. Right, again, some detailed implementations like what might happen and how it'll handle in HDFS, and then also the Pig, which I'm not going to go into details, but you can, those who are interested, you can have a look at it, how you may actually handle this. Right, let's move on to the other services. We are going to focus on three services, components, HBase, Scoop, and Flume, basically for improved data access. In first one, if you look at HBase, which will use column-oriented database, and you can have like billions of rows of data for rapid access. Scoop is again data for relational databases into Hadoop, and Flume is like streaming log data that you can handle, right? Then you can see the different the architecture, so how it basically handle. User can make a command to Scoop, and then you can have map task where we actually this could be handled with the data warehouses, or it could be coming from database or document-based systems, or even the relational databases. So irrespective of whether the data is structured or semi-structured or even the free, you can handle. And that could be output into the other components. Right. At the same time, Apache Flume we can use again, especially from the social media network data, to take it and put it into other components. Then we have what you call H catalog. Especially it is used for table and storage management layer of Hadoop. And then it support different components like MapReduce, Hive, and Pig. And then it'll enable user to store their data in different forms. Like you can put into CSV or JSON, more common formats. Then we will have Auro and Thrift. It is again what we call the data serialization and also the exchange services for Hadoop. So we can handle what we call the RPC communications. And then you have to have, because you are going to handle multiple different nodes we do. So you need this. And then we can use Thrift for the performance. So when you talk about the serialization in detail, it's your data structures in for the transformation. Now, why we need to talk about the serialization is we have to work in multiple nodes, right? Then we will have Apache drill. In Apache drill is the distributed query engine, and it will also support the schema-free model. So it's extensible, flexible, and it can use for dynamic schema discovery, because you can see the schema is not fixed, and we are going to work with multiple different data types, right? And then we will have Ambari, meaning like now you can see that we have many components in the Hadoop platform, and Ambari normally used as a place to monitor everything, especially the whole cluster. When you have multiple nodes, we can name it as a cluster so that you can actually use it to manage it, right? So simply we will use this for operational, control, right? Another, aspect of this is it will reduce the administration, and also the security in entire platform can be handled through Ambari. And then also the visibility. That means you can, for example, I told you, like in distributed environment, some nodes could be failed, and everything can be monitored through this, right? Right. Then coordination and workflows, we have Zookeeper and C. If you look at the Zookeeper, it's usually we say it's a centralized service for maintaining configuration, which is used to coordinate the large clusters of machine. So since the node can be failed at any time in the cluster, so you need to synchronize the data, right? So, and also you need a place where to, access services. So everything could be handled in the Zookeeper. Usually we say it's used for coordination. And then OSI we use for scheduling and the workflows. So workflows are common nowadays. So you can use for MapReduce jobs, and then Hive queries, pig scripts, and so on. So you can manage everything with OSI. Right. Usually you have talk about two things in OSI. One is we call OSI workflows. That means you can talk about the workflows, which consist of these MapReduce jobs, Hive queries, and pig scripts, and so on. And then you have something called OSI coordinator, which is again, you can create something called predefined schedules, right? And also you can focus on availability of the data. Right. The next one is Ambari and Veil. We can use for the development, which we have discussed earlier as well. But we'll focus on the Veil. For example, it is used for what we call complementary component. So how do it can use to handle how to run the services, which includes the Hadoop basically in cloud platforms. Okay, most interesting point is I know that in any big data is use it for predictions or understanding or identifying interesting patterns. So in Hadoop platform, this is called Mahout, which is the open source framework for machine learning algorithm. Now, remember the machine learning algorithm you use or discuss in traditionally might not be used for this because it should be scalable. For example, think classifier like nearest neighbor, for example. You might not search through entire data set because it's huge. That means you have to break into pieces and then you can handle. Even the building a decision tree, for example, might have to do in in a different fashion without directly using the whole data set. So which is we need special implementations. So therefore, not all the machine learning algorithms are available in these platforms, right? Still people are working on how you can actually create scalable machine learning algorithms. Right. So once you have data in HDFS, and then you can use how to find interesting patterns, and then this is actually, as I told you earlier, use common analytic platform. So you have support for classification, clustering, recommendation, and even the collaborative filtering. So those are like some of the um, um, implementations we have. Okay, there are multiple versions in Hadoop. Now, if you look at Hadoop versions, we can talk about Hadoop version 1, Hadoop version 2, and then we have Hadoop version 3, and so on. So and there are different revisions. For example, Hadoop version 2 came out around like 2013, and the 3 is around like 2017, and so on. So just to see like what has happened in basics, there are different changes in the Hadoop version 1 to 2. If you look at this, you can see in version 1, in the lower level, you have the distributed file system, and then how it actually manages, actually it's different in version 1. And you can see the one of the changes you can notice here is the yarn, that module. And then in top, usually you have the MapReduce. So there's no change of this. Then if you look at the Hadoop version 3, which is again the same, which will be again the lowest layer, we have Hadoop, what we call the distributed file system. And then we have again same yarn. We have, and then on top of this, you have MapReduce, and then other processing engines, right? So commonly, there are some not many improvements compared to the version 2, almost the same. Okay, let's the final few slides that I would like to discuss about the deployment considerations, what to consider in deploying this. One is whether you go for cloud or in-house, depend on your requirements, because if you think about implementing this in-house, you have to spend quite a lot of money on the infrastructure, whereas people are tend to now use to go for cloud environment because you pay for what you use, which is the model now people are interested and may be cheap in some of the places. Big data is big. That is another issues. For example, if you have if your data is it's huge, and sometimes it might be problematic from transferring from one place to another. So that is also another thing that you need to discuss, think about. Then big data is messy. I think any data mining, machine learning, and even the big data analytic projects, you have to spend quite a lot of time on the cleaning the data. And with the different types of data, this becomes again complicated problem. And then also the culture, also another dimension you have to think. Although these technologies are available, not all the organizations are willing to, spend or invest on these technologies, right? So this is also another thing that you need to discuss, right? And then you need to know like exactly what you do, because you have to decide what problems you want to solve, depend on your requirements. Sometimes you might not need this big data at all, right? So everything should be considered with what you need to do with the data. Okay, so with that, I'm going to conclude my sessions. Many of the things that I have taken, so I have listed some of the references I have actually used for this session. I'll also acknowledge their contribution to this session. I hope you got basic understanding about the big data, and applying big data knowledge is very useful. And there are some, products that actually you can directly use with the understanding of big data. So having said that, we'll conclude the today's sessions. We have 3 more minutes. If you have any questions, I'm willing to answer, or else we can conclude the session. Okay, then. Thank you. So we'll meet on Friday then.